Okay, hi and welcome to our talk, which is, that we're off to a good start, which is your forgotten friend inside Xcode, which is, of course, the interface builder. First off, I'd like to introduce us. This is my colleague Bernhard and I'm Matthias. We both work at a company called Kupferwerk, based in Regensburg and in München here in Germany. And we're an app agency, so we can work for a lot of different clients on a lot of different apps.
A couple of years ago, I couldn't imagine to work with Interface Builder. I always thought that my apps are too complex for it, and Interface Builder is basically only useful for sample code or rapid prototyping, for example. It's a nice toy, but not something I can do productive work with. And a lot of other people had or still have the same opinion and drop Interface Builder completely in conclusion. So I would say we have some kind of love-hate relationship in our community regarding to the Interface Builder. Here you can see the main pain points I had with Interface Builder. I was not really able to reuse my interface components. I got these conflicts when working with others on the same storyboard or zip file, for example. And in the beginning, the auto layout support was really terrible, and it was the reason for me to drop the Interface Builder. But I saw that the last Xcode releases constantly improved the Interface Builder and resolved a lot of the issues I had. And because of that, I gave the Interface Builder another try, and I changed my mind. Additionally to this, I learned some new tricks which transformed the Interface Builder in a powerful tool that I never expected, and I don't want to miss anymore. In fact, the Interface Builder has changed the way how I develop my apps now. Next, you will get an overview of some topics which we think played an important role on how we improved our Interface Builder workflow.
Okay, this is our agenda for our talk today. First off, we will dive into auto layout real quickly. Next, we will talk about reusability and tell you how you can reuse your interface components across different view controllers. Okay. Then we will talk about collaboration and organization, how you can manage working with a team and organize your interface builder files. And last but not least, we will talk about behaviors and show you that the interface builder, in fact, can not only do user interfaces, but it can also do behavior and logic.
We can't talk about Interface Builder without mentioning auto layout. Auto layout is really a topic on its own, and because of that, we will discuss it real quick here. Like I said before, in the beginning, the auto layout support in Interface Builder was really terrible. For me, it was unusable. So layouting in Interface Builder was only good enough for static views. And what I did is I created and configured all my views inside code for quite a while. And something like this, I was able to do this basically in my sleep. But if you have a look at this, you can't deny that this is some really tedious boilerplate. You have to do this in boring math. There is this annoying rounding inside. This just clutters up your view class, basically. And the view setup code is not even on the slide. So aside from the bad start auto layout had in the beginning, I think it has evolved great inside Interface Builder. And this is a sign that Apple thinks that this is an important technology. In my opinion, auto layout in Interface Builder can handle the most layout requirements we have in our projects. And compared to code, visually layouting your Interface Builder helps you to get a way better understanding on how this constraint system that auto layout uses works. And you also have this high-level overview, which is useful when working together with a designer, for example. With layout code, something like this is not immediately obvious at the first glance. The auto layout API is very well integrated into the Interface Builder, and the Interface Builder does all this heavy lifting for you. For example, when you got conflicting constraints, the Interface Builder visualizes that and offers you tips, so you don't have to do this constantly recompiling that you have with code. So I would say when using the Interface Builder, auto layout in code or manual layout with layout subviews is rarely needed anymore.
Okay, so next up is reusability. There are a lot of patterns for reusing your code, and most of you probably do that every day. And there are also patterns for reusing your views built with the Interface Builder, which are not as well known, we think. Often, of course, you don't want to reuse entire view controllers, but only certain parts of a view controller, only certain sub-views. And you can do that. When talking about reusing views, we first have to talk about reusing UI table view cells and UI collection view cells, because there's built-in support for reusing these kinds of views in UIKit, and Apple makes it really easy. The only thing, basically, that we have to do is we have to use a xib instead of a prototype cell. When using prototype cells, reusing these UI table view cells is not really possible, but refactoring those prototype cells to a xib is really easy, and then reusing is basically free. I'd also like to mention this library called Reusable, which makes working with views from the interface builder a little easier. Okay, I'd now like to give you a small demo. So, we built this little demo app for our talk. I hope you can see it. We will publish, or we already have published, the source code on GitHub, so you can check out later. We have in the demo app, there's a screen with all the social events that most of you probably attended yesterday. And there's also a table view containing the speakers at the conference. And as you may notice, the table view cells in both table view controllers look really the same. So I'd like to use the same table view cell for both of my UI view controllers. And we can do that. So let's jump into Xcode. And here you can see how we have set up our app currently. We have a single storyboard containing all our UI view controllers. And as you can see, we have 2 prototype cells containing the same layout. And we don't want that, we want to reuse it. So what we can do, I already prepared that. We can extract our layout to a xib, and I already did that here. And after that, we can then just reference our xib from our UI table view controller. And this is really easy because of the library I mentioned before, Reusable. And then we can just go ahead and delete our prototype cells from the storyboard. And when I build and rerun the app now, we should see that everything looks the same, and reusing my UI table view cell was really, really easy.
So being able to reuse your interface components is really important. And we just saw how easy this is using table view cells and also collection view cells. But what about ordinary views? Well, this is a little bit more unknown, but can also be accomplished with the interface builder. There are 2 roadblocks we have when trying to reuse regular views. First, we have the actual xib loading, and second, we have xib referencing, which means to reference a xib from another xib. Apple provides no convenient way to do these stars compared to the cell example you just saw. So we have to build our own little helpers, and I'll give you now some tips on how you can do this. Let's start with xib loading. At the top of the slide, you can see the standard way of loading a xib and creating a view. This method includes some drawbacks. We have stringly typing in there. We have to type in the interface file name, which is error-prone. And we also have to do this casting to our actual view class, which is also not nice. I think the goal should be that we get a similar behavior as we have with the cell example Matthias showed you, or with view controllers. So we can make use of this library Matthias mentioned called Reusable, and all we have to do is we have to conform to this nib Loibl protocol. And if the name of our nib file is equal to the class name of the view, we just need to call load from nib, and our view is created. Let's move on to xib referencing. This is a little bit more complicated. And I will now show you 2 options on how you can do xib referencing. The first one includes the more unfamiliar method called awake after using coder. You first thought we can use init with coder and return the loaded view, but unfortunately that results in an exception. So what awake after using coder does is it substitutes another object in place of the object that was decoded. And this is exactly what we want here. For this option, it's also important to check if awake after using coder is called from the referencing zip or from the real zip. We can do, for example, check the subview count when it's loaded from the real view and just return the result from calling super on it. And when we call this awake after using when awake after using coder is called from the reference zip, we have to do some work. First, we load the zip, like I showed you before. And after that, you need to transfer over some common view properties, something like the frame or alpha value, for example. And because we are using auto layout, you also need to transfer over the constraints. I would like to note that this method here works really great for simple views, but could be potentially problematic in combination with size classes. We haven't tested that yet, but yeah, just to note. The second option is to add the loaded nib view as a subview inside init with coder. This has the advantage that you don't need to transfer over all these properties and constraint and basically don't lose any context here. But you have to live with an additional intermediate subview, so you have an extra view level. What you also should keep in mind when using this method is you need to set this files owner's proxy, you probably know, of the interface file to the reusable view class, so that you break an infinite loop with this, and you need to link your outlets to this file owners after that. So I now give you a demo on how we can reuse a regular view in our example app. So what I want to do is I would like to reuse the top part of our speaker's detail view here, which is this image view and the label, and I want to reuse that in my event registration page, so that I got additional information about an event. The process of reusing regular views is quite the same as we just saw before from the table view example. So let's start with the interface file. So I extracted already out here the two components I want to reuse, which is the image view and the title label, and put it into a stack view, and that's basically it. So the label here, the layout here is pretty simple. And if I go to the implementation, that's also quite simple. I have my two outlets here at the top, and I make use of the first option of zip referencing I showed you, which is using awake after using coder. And the only difference to the slides are that I have extracted out my zip loading code and this transfer stuff into a category so that I can reuse that in other views, which is usually what you want. Okay, and the last thing here in our view class is this little configure method at the bottom. It just configures our title label and the image view. Let's jump to the storyboard and use this header view. So here is my event registration scene, and I want that the header view is at the top of this event registration view. So we have to drag in this view at the top of our stack view, and we just need to set our class name of this view to header view. And also my event registration view controller has an outlet to this header view, so I need to connect this outlet here. Oops. And now I'm basically done, but as you may see here, we have an auto layout issue. That is because the interface builder is not able to determine the height of our header view, so we have to give the interface builder some hint about the height. This is not really a problem during runtime, but this is only a problem during design time, so we can set a placeholder here. And for the width, we don't need that, and also the value for the height is only relevant inside interface builder. So the last thing I do is I refresh my frames, and if I run this now, we should see that we have additional information about an event. That was reusing regular views inside Interface Builder.
Okay, great. Next, we will talk about collaboration and organization. And some of you probably, if you have used Interface Builder before, may have seen something like this already. The storyboard from our demo app looks very similar to this. And probably this is why you stopped using the Interface Builder, because something like this, it just begs for problems. There are too many view controllers contained in a single storyboard, and you will get problems because working in a team is nearly impossible because you will have merge conflicts all the time, and also the performance in Xcode will suffer. But there's something you can do about this. You can modularize your UI and refactor your storyboards so that you have one storyboard per context and keep your storyboard small and isolated, just like you do with your classes in code. Some examples for this would be you could create a storyboard that contains all the view controllers that have something to do with your onboarding process, or you could create another storyboard that has all the view controllers with your settings in it. And luckily, refactoring storyboards is really easy because there's support in Xcode for that. And the Interface Builder or Xcode will even create storyboard references, so if you make use of that feature, you don't have to link your storyboards via code, and Xcode will do everything for you. And I will show you that now. So let's jump into Xcode again. And here's the storyboard you saw before. And on the top, there are 3 view controllers that make up our speakers scene. And I'd like to refactor them to their own storyboard. So I can just go ahead and select them, hit Editor, and refactor to storyboard. I give our new storyboard a name, and I'm done, basically. The Interface Builder created a new storyboard for us, and it transferred the 3 selected view controllers into the new storyboard. All the properties have been transferred, so nothing was lost. And if we go back to our main storyboard, we can see that the Interface Builder created a storyboard reference for us. So our storyboards are linked, and I don't have to do anything else. I would also like to note that you can, of course, create a storyboard reference on your own. You can just find it down here and drag it in. If I build and rerun the app now, we should see that everything looks the same, although I'm using 2 separate storyboards now, which makes working in a team a lot easier. Okay, sorry about that. The next thing I'd like to talk also has to do with organization, and that's secondary views. Secondary views are a small feature that have been introduced in Xcode 7, but they have quite a great impact because they solve a common problem in a very elegant way. The problem is this, and we came up with this term, the hidden view problem, and it occurs when you have a view controller that has different states. So, for example, you have an event registration page, and you have an error state and a success state. What happens usually is you drag in all those views representing the different states, and your view hierarchy becomes cluttered. It's hard to select things, it's hard to see what's going on, and it's hard to work with this. And there's a solution: secondary views. A secondary view is the view you can see at the top here, at the registration complete view, and it's basically a view associated with the UI view controller, or our main view. At runtime, when I want to use that view, I can just grab it from the UI outlet and add it using add subviews, as you do all day. Creating secondary views is also really easy. You just grab a UI view and you drag it into the little bar across your UI view controller, and the Interface Builder will create a secondary view for you. Great.
So collaboration is not just about working with other developers. It also involves working together with designers. And this plays an important role for many of us. You can only be productive if you work closely with your designer and understand how their tools and their workflow looks like. Sometimes coordination can be hard, And this leads to misunderstandings and time-consuming discussions. An example I want to highlight are the process of working with colors. Usually these designers provide you some kind of specifications about the colors of your app, something like text colors or background colors. And this is what most of you are probably doing, is you take this list with color names and values from your designer and then hack it into an enum. You have to probably do some conversion before, or like from hex. But I would say that this is not the best process to deal with colors, especially when working with the interface builder. With interface builder, you don't have access to these colors defined in code. And in the worst case, you end up with a color mismatch and your designer hates you. There is a better way how we can deal with colors and the interface builder, and this is using the color picker. The color picker allows you to create palettes of your app colors. You must put the color files into a specific location. You can see an example here at the bottom, so that the interface builder and other apps can pick them up. Luckily, most of the designers are organizing their colors in such palettes too, and use it in tools something like Sketch or Photoshop. So now we have this common format which designers can export and send over to us, and we can use it in Interface Builder. So awesome. But you may encounter situations you need to set the colors inside code. And to avoid maintaining your colors in two different places, you can use an open source library called r.swift. r.swift can generate an enum similar to the one you saw before. You just need to put in the palette file into your project, and r.swift generates an enum for you. So using color palettes was an example on how collaboration with designers can become more effective. The last topic we have are behaviors. Behaviors are a pattern for improving your app architecture. I first heard about it from an Objective-CIO article, and I was immediately sold, because behaviors help solving one of the most typical problems we have, and that are massive view controllers. With behaviors, you can extract out user interaction logic from a view controller, and you get small and easy to maintain classes. This is quite similar to separating out data sources from your table view, for example. Let me give you an overview on the characteristics behaviors have. Behaviors are responsible for implementing a specific role, which is usually UI-driven, something like validating an email. So behaviors really follow this single responsibility principle. With behaviors, it's also easy to avoid dependencies to app-specific code. So behaviors are isolated, which means it's easy to write tests for them. With behaviors, sharing is not possible only inside your app, but also across multiple applications, so that they are really reusable. Behaviors are built on composition, but also composable by itself. And to bring the interface builder into this, behaviors can be fully configured and composed using the interface builder by using tools such IB inspectables, outlets, or actions. And if you're familiar with reactive programming, with behaviors you can do reactive programming inside interface builder without using any library. Here are some use cases on what you can do with behaviors. You can build animations, you can do text validations, and you can also do something like this annoying keyword handling you have when you have multiple text fields inside a scroll view, for example. And after a while, you will end up with a whole library which you can reuse across multiple applications. To show you how behaviors work, I will give you a demo. We are doing a simple text validation for our event registration page. Before I switch to the interface builder, let me just quickly explain you how some properties of this text validation behaviors we have here are. First, I want to highlight this rules property we have. Our text validation is basically composed by rules, and these rules are performing the actual validation. So all the text validation behavior does, it loops over the rules and check if all rules are passing. Some examples for rules that we have here in our class are or this length rule, you can define a text range. You also have an allowed character rule, so you can exclude special characters, for example. We have a regular expression rule, and we also have an email rule. Next, we have the text field. This is the text field that we would like to validate, and we can connect this with an IB outlet. We can also connect multiple controls. So, for example, we can connect an UI button that should be enabled if our validation passes. And last, we have also an invalid text color, though as long as the validation is not true, the text inside the text field should be colored red, for example. So now let's switch over to the interface builder and configure our behavior. Behaviors are just regular objects, and with interface builder you can actually use typical objects. We are using one validation behavior here and one rule, so I need two objects. And I just set the classes here for our object. The first is the text validation behavior. And second, we are going to use the length rule. Okay, let's now configure our text validation behavior. First, I would like to mention that the text validation has a superclass which has this property called owner in it. And what this property does is you can bind the lifetime to another object. And in this example, I want to bind the lifetime of the behaviors to the view controller because that's what you usually want. Next, we're connecting our text field. And we would like to also connect this button here, which should be enabled if our text validation passes. And last, we connect this length rule here. Oops. Okay. So the validation is composed by rules here. And the last thing I need to do is I need to configure my length rule using IB inspectables. And I can set here a minimum and maximum character counts. And you see here the advantage of using IB inspectables. You can all do this using the interface builder. And I just set the minimum character count to 4, for example, and the maximum character count to 100. And when I rerun my app, we should have hopefully a working text validation. Okay, so let's type in a name here. I type in Matthias, and you see that after the third character, this button at the bottom gets enabled. And that was using behaviors. Yeah.
Okay, cool. Of course, we cannot leave the stage without talking a little bit about the limitations that the interface builder has. Well, there are some, and these are just some examples, really. First off, the documentation is nowhere near as good as the documentation that Apple usually provides for frameworks like UIKit, for example. Also, parsing objects using segues across different view controllers is really error-prone because you have to have access to these objects that you want to parse in different places, and it makes it very hard, so we probably won't use that. Also, source control still is an issue because the interface builder will make modifications to your files even if you're just viewing them and not really making any modifications. And those modifications, they don't really do anything, but the files will keep lighting up in your source control system, so that sucks. Okay. In conclusion, we'd like to give you some final suggestions on what you should do when you want to use the interface builder. Very important, keep your interface builder files small and modular, otherwise it's impossible to work in a team. And also use the interface builder where it makes sense for your application and where it makes sense for you. And don't force yourself to use the interface builder for everything. Just drop back to code if you see that what you want to accomplish is not really possible or very hard using the interface builder. And use code and the interface builder both in the places where they're best at.
So thanks for listening to our talk. The unofficial UIKonf app we demoed is available in GitHub. Matthias already said that. We've included also some additional examples that we couldn't cover here. The slides are published too.
You can find the link to the slides in the README on GitHub.
If you have any questions, Matthias and I are around today and tomorrow. Feel free to ask us any question about the interface builder. And enjoy your coffee and the rest of the conference.
Great. Thank you very much, guys. Would you like to get some questions now, or is it?
Yeah, we can do questions.
Yeah. All right. So, do we have some questions for them now? Yes, please.
Yeah, thanks for the talk. I have a question about these color palette things. So
Yes.
you showed like the path to the file was like home dear library colors, something like that. Does it need to be in that directory, because that would make it very hard to share it with my teammates? I would want to like check it in my Git repository or so in the projects directory to easily have it available for everyone that checks out the repository from scratch, for example.
No, unfortunately, it has to be in that directory, as far as we know. This is not only true for the interface builder, but also other applications like Facebook or Sketch, for example, will pick those color palettes up. What you could do probably is just symlink it or something like that. Yeah.
Yeah. Okay. Thanks.
You're welcome.
Thank you. Another question over there, and then another was back there. So, first here.
What do you think about reusing views, custom views, using view controller containment?
Yeah, that's another option you have. It feels, in my opinion, for some, it's not so lightweight. It's a little bit more heavy, but yeah, you can also use that, and there is also support inside Interface Builder for view controller containment. That's another possibility you have. Yes.
Okay. Another question over there. I see like one hand. Yeah, there, over there. Go. Perfect.
So which of those features you demoed are iOS 9 only? So which ones can't you use if you have to support iOS 8? I think it's the secondary views you demoed, I think.
The secondary view you can also use on iOS 8.
Okay, and
they're just an Xcode feature, as far as I know. Of course, we use the stack view in our demo. That's iOS 9 only, but the layout is not really that complicated, so you could just create the same layout using regular constraints.
And the view controller reference are also an iOS 9 feature, but yeah, you can basically split up your storyboard in iOS 8 too. It's not so convenient.
yeah. Okay, thank you.
All right. Another question there, and I see another hand here. Yeah.
Hi.
Go on.
Do you have any experience using code reviews with Interface Builder? Like, how do you actually look at those changes and make sense of them if you, I don't know, review them on GitHub or stuff like that?
Yeah, that's a difficult question. We probably should have added that to the limitations slide. What we do typically is we just check it out and look at it in the storyboard. Yeah.
And last question over here.
Yeah. Hi. Thanks for bringing Interface Builder back into the game, because I think it had a very hard standing in the last years. I don't have a question, but I want to just add something. So from my experience, it was very good to use Interface Builder in some projects because, yeah, you had a kind of backward compatibility with old code that Xcode over the years ported your code automatically to new Xcode versions and to new iOS versions. If you have all these UI and layout stuff in the code, then it was partly a hard work to do this manually and to adopt it to new iOS versions, and that's what Interface Builder is doing for you from the scratch.
Yeah. Like I said, in our recent projects, we were able to cover most of the layout requirements we have only using Interface Builder and auto layout. Yes.
All right, thank you very much again, guys.